We're live. My guest today is Greg Osuri, CEO of Overclock and founder of the Akash Network. Today, we're doing a deep dive into Akash, how it works, and why it's an important part of the future of cloud computing. We're also going to talk about, honestly, what I think is the most exciting thing happening on Akash, which is that they'll soon offer GPUs, and that will enable all sorts of applications in machine learning and large language models, which of course are all the hype right now. We'll also spend some time looking at the GPU market and unpacking what's going on there. AI plus blockchains, all the buzzwords today. We'll also be talking about his views on the broader Cosmos ecosystem. I'm also dying to find out why he thinks decentralized experiences are better than centralized ones. So if you enjoy this content, please consider sticking with us. We're validating on FMOS, Quicksilver, Osmosis, and Juno. Just look for interop in the active set. And if you're in Paris this summer, I'd love it if you come to Nebula Summit. It's the Interchain Builders Conference that's happening on July 24th and 25th. It'll be 2 days of technical talks about Cosmos, IBC, and the Interchain. No panels, no suits, just tech talks. The second batch of early bird tickets just went up. You can get those at nebular.builders. My guest, Greg Osuri, is coming up next, right here on the Interop. Hey, Greg. Thanks for joining me today.
Hey, Seb. Great to be here. Thank you so much for having me.
Yeah, it's been a while since we're trying to plan this. I'm glad it's finally happening, and it feels like it was good to wait because there's a lot going on in Akash, and I would love to kind of deep dive into the technical underpinnings of Akash, but also all this work you guys are doing in the GPU space. So yeah, for people who are not familiar with Akash, can you give us a high-level overview of the vision and what does the product look like today?
Absolutely. So I think Akash has always something going on, but this is definitely the most important moment for Akash. So we're at perfect time. For those of you that don't know what Akash is, it's essentially what we call a supercloud. A supercloud is a cloud. Some could say it's evolution of how we look at the cloud. Essentially, the idea behind it is there's so much heterogeneous compute, right, all over the world. And if there's a way to federate this compute and give a homogeneous experience to a developer or builder, we can use these compute resources in a more efficient way. So Akash is the first supercloud and only decentralized supercloud. The research for Akash has been, happening for quite a lot. Really, it began with Cornell writing the paper on SUPERCLOUD and Overclock Labs team taking the paper and extending that and adding the marketplace component to it and making it permissionless and decentralized, right? So right now, Akash is a functioning platform, and several Cosmos projects, including Osmosis, Mars, and quite a lot of Juno, Stargaze, and all these incredible projects, are deployed on Akash in some form or the other. And we are right now, we've progressed quite a lot, and Akash also happens to be the first IBC chain, right? If you remember, the first IBC transaction happened between Cosmos and Akash Network. And we're also one of the first few projects to adopt Tendermint in 2018. So we've been, in the Cosmos ecosystem for a very, very, very long time. Also, Osmosis pool number 3 and 4 are Akash, right? So if you remember those days of 3,000% APR. So we've had quite a lot of journey, good old DeFi's, the good old days. We've been along, and now we are on a pinnacle of the most important upgrade for Akash Network, introducing something called the GPUs. We're pretty sure we'll get into that very soon, and that's in a nutshell what Akash is.
Yeah, very cool. I'd love to talk a little bit more later about how teams in the Cosmos ecosystem are using Akash and how they're leveraging it. I use Akash a little bit, like I guess last year, I was hosting a bunch of websites on there, like my personal website and the Interop Ventures website, and I really enjoyed it. I mean, it felt really good to be able to deploy a website to like a decentralized compute cloud and just point your Cloudflare to that link, and it just worked. The issue that I was kept running into is that I would go to my website once in a while and it would just be gone, and I didn't know why or for how long it had been gone. And I think probably after looking into it now, those resources might have been reclaimed by the people providing the infrastructure. That seems like a UX problem that um, kind of sucks. If you have like resources up there and they're falling out off the network. What kinds of what's the biggest challenges that you guys have when in terms of managing all these resources? Like, how difficult is that?
So I mean, it's a very good point. So Akash is in such early stages, right? It is purely non-custodial. One of the most important aspects of our network is the non-custodial nature as well as the open source nature of it, right? The challenge with non-custodial interfaces, being a pioneer, is we don't have engagement infrastructure for the user that you're used to in Web 2, like notifications or auto renewals of things of that nature, right? Auto deployments and things of that nature. Even though the platform works as advertised, the UX hasn't quite caught up. And the challenge is really doing it in a non-custodial way. And some platforms take the shortcuts. They actually offer custodial solutions to offset some of the non-custodial capabilities. But Akash has been very, very strong in holding to the values of non-custodial nature, and that's reason why your website probably went down. Our biggest challenge right now is churn. Right? So we get adoption, but we also have quite a lot of people leaving, and there are two primary reasons for that. Biggest reason, I would say 90% of the time, is because the deployment runs out of funds, and the deployer, the tenant, has no idea that they need to renew, and there's no email addresses to email them or notifications. So, I mean, perhaps you ran out of funds in your escrow account, and then you don't even realize that because you're probably not monitoring that, right?
Yeah.
Second big challenge is reclamation, right? So providers can reclaim resources. In a scenario like a website which doesn't have state, it should automatically deploy to a new provider if you set it up that way. But most people don't. Most people just deploy a Docker container and forget about it. So yes, there are a lot of these like small nuances, and majority of them sort of like cause this churn, right? Even the platform works as advertised. And those issues are getting solved very, very quickly. And they're getting solved in an open and distributed manner. That means the team that created Akash Network is not the only one solving these problems, but there are 10 other teams, be it Fleek, be it Speron, be it CloudMoss, Praetor, and there are a lot of these applications that are addressing these capabilities of pitfalls in their own way. Some non-custodial, some custodian. That's the beauty of an open cloud. And another, from a churn standpoint, if we control the churn, we will see net positive growth. But also from a on ramping, or like using the platform or converting the platform, converting a non-user to a user, the big challenge there happens to be getting access to tokens, right? In this increasingly regulatory realm, which is extremely hostile, it has been so far impossible for us to provide credit card-based payments because it's a very regulated space. And so far, the experience using credit card systems has been subpar. But now you have companies like Stripe, which we all use quite a lot, and companies, even to some degree, Cato Money. I've seen a demo. It looks very, very promising. Are offering credit card on ramps, and Akash soon will enable stable settlements. Right, that's also been a challenge, especially for long running workloads. because you price the workload in AKT, and AKT is volatile, and so on in a good enough period, you may actually lose money or gain money depending on how you're looking at it. But
Yeah.
that's subpar experience, right? And I think that has to be fixed. So these two,
Yeah, and you guys are not the only ones sort of dealing with that problem. I think like it is an experience problem that needs to get solved across the entire crypto ecosystem. Is how do you get access to crypto, and there's always this onboarding problem. One question I wanted to ask you, like sort of as we maybe start diving in here, is like public clouds are great, like AWS and DigitalOcean, and all these things are amazing. Why do we need Akash? Like, what is really the fundamental thing that you guys are trying to do, and what does that look like in a more long-term, like 5-10 year vision?
So three main reasons. There are a lot of reasons why decentralized systems, are weak. But in terms of cloud, right? The first big challenge is as you scale out on a public cloud, you end up paying quite a lot more than what you should pay. So your expenses are outrageous. So if you look at any public filings from companies that were built on the cloud, like Netflix's or Dropbox's, even Asana's, you notice over 50% of the margins actually go to a cloud provider. And that's not sustainable in most cases. And there's quite a lot of work done by companies like 37 Signals, companies that actually came back from the cloud to a data center, saving quite a lot of money. But again, in a data center, the challenge is, underutilization, so because of over provisionings, right? Because it takes quite a lot of time to put a server on a data center. You tend to over provision, and then you just sit on underutilized resources, right? So that's one problem. And second problem is the stifling of open source software. We all know what happens when companies like Amazon see a successful open source software, and they tend to take away the core business model for these open source companies, which tends to be, hosting, right? So we see quite a lot of dampening of revenues for these open source companies, Databricks included, and quite a lot of filings, and you see quarterly reports as to they had to address how do you deal with the Amazon threat, right? And the third reason is anti-market forces, right? So Amazon Web Services is currently under investigation by U.S. government for antitrust, the monopolistic behavior. And this is a natural sort of like cause of hyper concentration of power. Corruption always comes with power, even though the company may not have intentions to operate this way. It just nature and organic to have this concentration lead corruption, right? So, and the solution really is to claim sovereignty. How do you get back the power that we gave? And through these anti-market forces, also you see censorship, right? So you see censorship both on political biases, also you see censorship on like business biases or business profits. Companies today that are doing machine learning cannot get these GPUs, the high-end GPUs we call A100s and H100s, on the cloud unless you have a special deal with someone higher up in one of these cloud providers, right? So they selectively choose which business and which company gets the resources. Thereby, they selectively choose which company should be successful. OpenAI got a big leg up because of this reason, and that's not fair. That's not fair to a lot of the innovators, which is a foundation for our economy and our society to get priced out of these resources. That's why we need if you consider cloud to be the fabric that holds a society, we need this fabric to be open. We need this fabric to be governed in the public and resources allocated in the public, rather than a single corporation doing it in a complete opaque manner, right? And overall, you combine this,
this idea of SUPERCLOUD, I think, which we'll talk a little bit in later on, I think kind of touches to that. And, how do we best govern this infrastructure? One thing that I've sort of noticed over the years, covering crypto and being in the ecosystem, is like, there's been lots of projects that have attempted to do decentralized compute. And then to some extent, projects have tried to do decentralized storage. Those, I think, there are some signs of success there. But on the decentralized compute side, like, we have projects like very early projects like Golem and iExec. They're based here in France, and I haven't followed up with those projects so much, but it feels like they're not massive successes, or like adoption is slow, and they're not like making headlines every day. Why do you think that is? Is it just like a timing thing? Are we at a point now where it makes more sense, or was there something kind of fundamentally wrong with some of those earlier iterations of decentralized compute?
Right. There are lots of things that went wrong with the earliest projects, and the main reason I would say is over focus on technology than the market. Right. So a lot of these compute providers, be it Column is a prime example, they over focused on verifiability of compute, general purpose, tried to do a general purpose platform, and then ended up building something that's not usable. First, they launched an Ethereum. We all know how that goes, right? High gas fees to deploy a blog is not okay in general, but you can't even deploy a blog. It's basically machine learning workloads. That's what they're focused on. But the challenge with Column was you have to rewrite your entire application to suit their framework, which is not the best framework. So they had to, well, fighting the non-custodial element it's in itself is extremely hard, but then trying to change the source code base to suit a decentralized network for a value that's not very obvious, right, is very, very hard, right? So that caused failure. I think the Golem's usage is like $7 a week. They have no new users at all. It's just there. It's just a zombie project, right? iExec, on the other hand, went through a few iterations, but they began in very similar mode as Golem. But I think they've, transitioned to more of a Docker-based. They're doing some work. I haven't really seen any latest successes, but iExec is very batch optimized, not necessarily latency sensitive. That means you cannot deploy a WordPress website with a MySQL backend on it. You can do batch workloads, right? And all the workloads are priced in public. It's a different model altogether. It's not what you would consider your typical, your application running on Amazon deploy onto iExec, right? And Akash was a first general purpose platform, in the sense you can take a container that's literally running on GCP or Amazon. Most likely, if you're using something like a Docker Compose, you can take the Docker Compose file with some modifications, deploy onto Akash, right? And that was a key innovation Akash introduced, and execution happens off chain. We're not the first ones to do that, but we're the ones to sort of really embrace that off chain execution, and the chain becomes a coordination and a settlement mechanism at that point, right? So the chain becomes a very lightweight component, and that goes away when you're interacting. So the look and feel really feels like a super cloud, right? That's really the idea. So you get a very homogeneous, very familiar interface, Docker Compose style interface, where you have the resources very heterogeneous. And Akash also has this powerful configuration language called SDL, which is like an orchestration language that lets you be extremely complex or extremely simple. It's very, very flexible language, and with that we were hyper focused on open source and community first approach. So with that, we were able to have a good ecosystem of projects building on top of Akash that helps users adopt Akash, and that list is growing as well. So a lot of things went wrong with the early set of cloud computing projects that were very ambitious. And the difference for Akash was we were very market focused. We were very focused on what the user needs and what the market is asking for. It was very, very clear. It was not verifiable general purpose compute. Verifiable compute was for deterministic compute, which makes sense. Verifiable compute is impossible for general purpose compute. Right. So, and we really took that and we introduced a reputation-based system, and a lot of other projects came after Akash that took that model and had success as well.
Cool. Yeah. So earlier we were talking a little bit about the user experience challenges that you guys are facing, and I mentioned at the top of the show that you thought that decentralized experience was better than centralized experiences.
Right.
Why do you think that is? And I think some people would agree with you, others would disagree. Yeah.
Yeah, so the non-custodial nature of the system makes for extreme composability, right? And and also from a safety standpoint, and just the experience of logging and authenticating in a non-custodial manner, where you know your information is not shared and you know exactly what kind of information is there. Right now we use a browser plugin or a browser which is extremely subpar, but imagine if that device in itself can give you the authentication mechanism, right? Whatever device you're using, and you extend that. So uh, and the non-custodial nature also calls for that, and along with interoperability calls for much better composable applications, right? So I, as a developer, do not need permission from someone else to use a protocol, but rather build a system that is hyper integrated, hyper like converge, right? With not having to worry as to how I should secure a user's credentials or private information. Gives me a lot more power to create incredible applications. So the on ramp is a challenge. Engagement is a challenge, and these two problems will get solved, and they are getting solved very quickly. And once this is solved, the user experience of using a decentralized system is significantly better than using anything centralized, right?
Yeah.
Because for passwords you need a password manager, right? And that's a big attack vector. With this, you choose where you want and how you want to secure ID, and that gives for a much broader set of options in terms of control, right? So I can choose my device as my secure mechanism, or I can use a ledger, or I have infinite possibilities. And as we see more builders using these possibilities and innovating on them, we're going to see significantly better experience. I mean, if you remove the on-ramp part, using Uniswap versus using a Kraken, right? Like just the experience part is incredible using Uniswap. It's like a couple of clicks and I'm done, except for the
Yeah.
MetaMask, right? Like remove all that stuff.
Yeah. Cool. Let's dive into some of the technical aspects here, because like I said, I use the Kosh, use the interface, or at least the application that you guys had. I'm sure it's been updated since then. I should probably check it out again. But I was always curious, like how it works under the hood, and who are the network participants, and specifically, like I'm curious, like who's running this infrastructure. Is it like mostly at home users, or is it people who are deploying Akash on data center infrastructure? Is there a range of users, and what are some of the challenges that come into running a network of computer resources with different uptime and latency and connection speeds, and how do you manage all that?
Great. So to understand Akash, you really understand the actors, different players, right? It starts with the tenant, which is a user, and then you have the provider that provides compute. Then you have an auditor, which essentially audits providers, and then you have validators, which secure the blockchain, right? We all know what validators do. They secure, manage the blockchain, they govern the blockchain, and delegators delegate tokens to them. And the providers provide compute, but how do you know who's running, right? Your question, who's exactly providing this compute? There is a decentralized auditing mechanism where auditors actually do off-chain verification and post those proofs on chain for someone like you to go and actually verify. So there's a section in your SDL file called audited attributes. So you can choose an auditor that you want to trust and get a web of trust mechanism through that association. And it's very, very common to see the actual provider that's deploying. You'll see Equinix's of the world, Cherry servers. You have a ton of these like I would say like tier 5, tier 4, tier 3 data centers. And then you have just companies with excess capacity, right? So we're seeing quite a lot of trend now with 37 Signals, for example, which created Basecamp and Ruby and Rails and whatnot. They themselves are bringing data centers in-house, and with excess capacity, for them it's beneficial to deploy to provide the compute on Akash, right? So companies are becoming their own cloud providers as the technology gets commoditized in terms of containerization, and realizing that you can actually offset some of the costs by putting the compute on Akash. So trying to be sovereign at the same time scaling is really what we offer for providers, right? In the sense that, hey, you can actually use your compute, offer that, or when you want more, you can actually get to the network. So with GPUs, we see a little different type of user base. A big set of users or providers are former ETH miners that were doing proof of work mining. A lot of institutional miners that are Hut 8s of the world, of the clouds. I think they're offering on the network. They are just offloading the high-end GPUs that they have. And then we are going to see professional miners that were not institutional but have smaller colo capability or even home capability with not a latency sensitive, not capacity that's data center grade, but good for batch jobs, right? Like high-end GPUs.
So you're saying like you have cloud providers like Equinox and some smaller cloud providers that are deploying Akash on machines that they're not utilizing. Is that right? Like they're leveraging Akash to essentially offer up their excess capacity?
Correct. Excess capacity is what we're going for. And soon you'll be, we're also working with some of the hyperscalers to enable unused capacity for their pre-committed users. So a lot of times when you are a company, if you want to get access to some of the high-end resources, you have to pre-commit a certain amount. And more often than not, you're not using this pre-committed amount. So it's beneficial for these customers to put their compute on Akash, and cloud providers like that because it's helping their customers and helping them sell their pre-commitments quicker. And especially in GPUs, because companies like Lambda Labs, which is quite popular in GPU cloud, their users are buying up the compute just to have access to the compute, and they're not using it. So that hurts everybody, right? So we're helping those, essentially creating a secondary market, right? That's what Akash really is. For this unused cloud compute, so basically you'll get the same exact thing you would get on Google or Amazon for much cheaper, right? So using Akash.
Okay, so I didn't realize that this was. I saw. I knew that there were some actual cloud providers and data centers deploying Akash. I thought these were people that were deploying Akash on, like, buying up some server space and deploying it. I didn't realize the data centers themselves, these companies themselves, were actually doing this. So
the companies are not doing it. It's the customers of the companies, right?
The customers, so, right? Okay.
We may or may not have something in the works, but really what we are making is making it easy for these people to deploy onto Akash or provide to Akash, right? Because we will be making some really good announcements very soon. You'll notice the work we've been doing in this sphere of like enabling pre-existing customers on the cloud to deploy on Akash. But that's a huge problem. I mean, it's a huge pre-commitment problem, right? There are even banks that approached us to a point where they could finance some of these companies to get pre-commitments, and in order to service their debt, put that on Akash. So there are lots of creative sort of ways people are looking at deploying Akash, and soon I think our real vision is machine learning companies should own their own GPUs, because that's ultimately where the sovereignty stands, and put that on Akash when they're not using it.
Okay, interesting. So Akash then acts as a market for compute where actors can come in and out of the market, and because they're offering resources that they otherwise wouldn't. I mean, it creates more fungibility in the compute market as a whole, where you don't have this sort of fungibility between one provider and another provider, say between like Amazon and like Equinox or some other tier like OVH or whatever. And by leveraging Akash, you sort of create this market of compute resources that can come in and out, and it's just a lot more fluid and fungible.
Correct.
Yeah, I feel like I've got a whole new sort of view on Akash now after explaining that.
Yeah, it's funny because like a lot of the cloud providers we actually talk to, they acknowledge the problem with the cloud. They acknowledge costs are extremely high. They acknowledge that it's, the market forces are not very. I mean, the company may or may not act in the best interest of the market. All of them actually acknowledge, and they're very pro decentralization. Surprisingly, a lot of the employees that work at these large companies, after talking to them, we realize, even though our paper written 5 years ago talks about the industry as a problem and points out, but in order for Akash to be successful, we need participation from everybody. Akash is a market, is a permissionless, decentralized market. And the mission for Akash is to ensure the tenant, the user, gets the best deal, right? No matter what cloud provider you are. And we have nothing against like cloud, right? I mean, cloud, I think, has done a phenomenal work in enabling, giving access to companies that couldn't get access to a data center. So cloud played an incredible role. And now we need to think about evolving the cloud to a super cloud, right? And in order for the super cloud to be successful, you need participation from the big guys, or else you'll just end up being this fringe, dark network, right? So I think in a year or two, a time frame, you're going to see quite a lot of like participation, and things are just getting easier and easier and easier in terms of how a provider can come online or a tenant can use. And as that progresses, it's not hard to see how Akash becomes a secondary market for cloud grade compute.
Yeah. So how does it, like, how do you, we talked about this problem earlier where resources can get reclaimed. Now, of course, that's an issue if you're, running a website or something that's publicly facing. I mean, any kind of compute, right? If you stop that compute while it's happening, that might that might affect the user of that compute resource quite a bit. If we look at, say, cloud store or decentralized storage, there's often this replication aspect to it, so that the resources are spread across different nodes. So, for example, in Arweave, the resources are spread across the network, and so there's this replication, and that ensures that the resource stays online, for a long period of time without any downtime. For compute, that's different. You have like a VM, right? That sort of like has a runtime, and it is running some computation. If that resource goes on offline, it can't, or at least I don't think so, it can't just sort of pass that on to another machine without having provisioned it and everything. So how do you deal with that? Is there plans to create more robust sort of mesh of compute that would abstract away some of these lower layers?
Yes, good question. So if you think about it, any resource on the cloud, even non-cloud, there's always a time the provider reclaims a resource. It could be a year, it could be 2 years, it could be 3 years, doesn't really matter. There's always a time a provider will say they're going to shut down their instance. They have to retire it, right? So there's always a reclamation time for a resource on the cloud. It's just that it's not obvious how long the reclamation time is. It's not very clear. I think first thing we need to solve in Akash is you're muted.
Yeah, but it's also seamless for the customer. Like a customer doesn't see that resource coming offline, because typically cloud providers will just move that resource to another like actual machine.
Not really. No.
VM, right? No.
No. They give you a notice. They give you like a 6-month notice, a year, and they give you a good long reclamation time, and they can't just move data over, right? Because that could cause a lot of damage, because the redundancy and replication is very workload specific. Every workload has different ways of how they do replication. We really, not to get too technical, but it really comes down to consistency of the commits, of the writes, right? Immediate consistency versus eventual consistency determines how you replicate the data. So you can't just like take a data blob and put it while it's under processing. At rest is a different story, right? That's why storage networks have easier redundant mechanisms. The point is, there's always a reclamation time. Only question is, how long do you get? So Akash, that reclamation time is not very obvious. So the first thing we're going to solve is providers advertising the reclamation time and sticking to the reclamation time. So you could get a notice saying that, hey, your resource will be reclaimed within a week or a day or an hour, right? So, and then you can choose a provider based on the reclamation time. So something, if you're deploying a database and you want to be like, I want 6 months minimum reclamation because it's going to take me 6 months to move the database over to a new server, right? Or if you're running something like a machine learning, I'd be like, hey, give me 1 hour. I just need to stop this job, reclaim to another job, right? When you know reclamation, you can actually automate the reclamation in a much easier way. Uh, each uh, each transfer is workload specific. And second thing is, if you're running mission critical, you always have to be redundant. Always have to be redundant. So I always have minimum a quorum for me, a set of three nodes minimum, 3 to 5 to 7, whatnot, odd numbers. The way I run my workloads is I have on Akash, you can specify different providers in the SDL file. You can have three providers and running it usually three different regions and have a load balancer in front of it that'll do the routing with the health check on the container. I know it's a little complicated, but it's typically how you run a production grade infrastructure. And from a state standpoint, what I do if I have a Postgres server, for example, depending on the storage, I mean, Postgres, I would do a master, sorry, new words. We would do a leader follower uh, replication model with a hot failover for the follower to elect as a leader using the quorum in case of a a fault. So what Akash does is it is extremely strict in enforcing these practices, and you have to do these practices, be it centralized cloud or decentralized cloud, doesn't really matter. Akash is very, very strict. If you don't do them, you will fail, right? And that's happened to you and happened to a lot of people, and that causes churn. But the point is, it's extremely strict in enforcing these practices. Cloud providers are much more lenient, right, in enforcing. But I believe in order for you to run a redundant system, you have to plan redundantly, and Akash is unforgiving in the form. Like, think of Akash as this system for builders that know exactly what they're doing, right?
Yeah.
It is very, very powerful, but it demands quite a lot of work from you, and that is a user experience problem or whatever you want to call it, right? And that's getting solved very quickly. And we introduced something called a console. If you recently console or Akash network, and in that you'll notice topologies as part of the deployment packages. So you can actually deploy a multi-leader or multi-follower, leader follower topology. That's application specific. Obviously, you could do like workloads in DMZ. You can do all kinds of distribution, and essentially packages the best practices as to how to deploy on Akash, and packages that in a packageable in a deployable manner using a beautiful non-custodial interface, right? And uh, so it's reclamation, is not as foreign as you think. It's just not obvious on different. There you go. You can actually really you click on Akash on top. Deploy now. And you'll see like an RPC node, validator node, Sentry node, right? You'll start seeing like other topologies, and you can actually you'll go ahead and do a live demo. It'll be fun. Check essentials. This is a missing certificate. Connect your wallet. Yada yada yada. Insufficient. Yeah.
Yeah. Okay. No, this is cool. I'll have to check this out. Yeah. I mean, I've heard a lot of people talk about running validators on Akash. And so from this here, it looks like it is possible to do that. But one of the issues I think was that the keys, your validator keys are effectively on someone else's machine, which is the case for any validator that you're running in the cloud. But here there's perhaps like another intermediary in the middle that is not the cloud provider. How does that work? Like, what's the best practice for running a validator on Akash? Is it a good idea? And how do you manage the keys?
Right. So you use audited attributes, and some providers like Equinix that directly provide. Some providers like Cherry servers that people love. They're direct providers. They're direct providers that can be verified using these attributes. So if you're concerned about someone being a middleman, you can use a direct provider. And second, you shouldn't really put keys in any provider. As a matter of fact, you should always have a mechanism to, you know, to offset, right? So I would recommend using something like a remote signer, Hawkrux, or some of that, where you actually sign the keys in a completely different system.
Sure.
That's not the system that's that's processing your transactions, right?
Sure,
So
but
that way,
I think like a lot of validators just have like their signing key on the server and they're not using Horcrux. I mean, like a lot of validators I think do that.
right, right.
Yeah.
So best practices, remote signers. If you're concerned about middleman, use a direct provider, Equinixes and Cherries, and we have quite a lot of direct providers. Yeah, so but I would choose remote signers as a best practice for anything. As a matter of fact, any secure setup.
No, this is cool. I didn't know that like you had this tool that just allows you to deploy an RPC. I mean, this is pretty useful. I think like for the Cosmos ecosystem as a whole to have this.
Yeah, especially like bottom providers that are not profitable in these market conditions. It's very, very hard for a lot of these folks to pay the bills, and I think we should start considering something like Akash. Cherry Service is a great provider. They're directly providing compute for Akash, and they're, I think, running quite a lot of Kava nodes with Cherry. Highly recommend them if you're thinking about deploying. We're also working with a lot of other direct providers to come online. Hut 8. Hut 8 is a actual proof of work miner, and we have Web3 Cloud, which is very, very prominent in Ethereum ecosystem. A lot of these providers want to get into Cosmos, and actually like looking at Akash as a way, because another way to think of Akash is it makes a average cloud provider more professional, because they have the tools now that is and the ecosystem along with it, right? So you have Fleek and all these amazing tools that are integrated into Akash, meaning these providers now have all these tools for free that they don't have to develop, right? So a lot of these providers are looking to plug into Akash, and as Akash gets more more mainstream and more, I guess, as awareness grows, we're going to see this increase. And also Akash is pre-incentives, so we have no incentives for providers, and that's going to change very soon. And we're being extremely careful on how we're looking at incentive design. We've looked at every possible incentive design, and we have to be cautious in how we incentivize providers, because so far it's been not optimal in the whole crypto space, starting off with Filecoin to Heliums of the world. And you look at a lot of these incentive models that are not really didn't deliver to the expectation.
Yeah. I mean, listen, if you can help me get delegations, I'm happy to set up to figure this out and set up a validator, an Akash validator on Akash, and
do it.
Yeah.
Meta. Although it's interesting. I think Akash doesn't really. There's one challenge there running Akash validator on Akash itself. Even though the validator, the provider does not depend on the blockchain to execute, they may terminate your lease if they don't get paid. So depending on when the provider is claiming their payment, if the blockchain is down, that could cause a non-payment or issue, depending on how the provider is set up. I think some of them are like, okay, if you're not able to talk to the blockchain, don't do anything to the workflow, just keep running. So but that could be an issue, especially during upgrades. Akash didn't have any unplanned outages so far. We've been very, very lucky. And again, I don't want to jinx it. I mean, it's been live for over 2 years, and it's been great. Every outage we had was planned outage during mainnet upgrades, and usually that Cosmos, right? You all know how that goes with validators, the dance we do every mainnet upgrade. But so yeah, I think you can run an Akash validator on Akash itself. It's pretty cool.
But you could run any other validator on Akash. I guess like the issue here is like okay, cool,
absolutely. I mean, with a big challenge again is like paying with AKT with
Yeah.
USDC payments that's coming very soon. I mean, it'll be very, very obvious. Like, hey, it costs like $10 a month, or like very, very clear cost
Yeah.
advantage.
Yeah.
Yeah.
Why does Akash use Docker containers, and are there other VMs that is it possible to deploy with other VMs? Like I've heard from a team that you're familiar with that like WASM VMs are very useful because they allow you to effectively know the compute resource required before running, and they're also more efficient. And yeah, are there any plans to leverage WASM? You know, either as like an alternative or a replacement to Docker. Or, yeah, what are your
Yeah.
thoughts there?
I thought we looked into it very seriously. My background, I've been an early contributor to the cloud infrastructure, container native world. I mean, all the way from 2013. I was uh, 2013 was heavily hypervisor world, right? So you had VMs as the primary mechanisms to ship software and deploy software, and they
Yeah.
were mutable, so that was not great, especially with downtime, right? So I was hyper focused on solving the parity problem. Essentially, when you deploy something, how do you ensure the target machine has all the dependencies, and containers happen to provide the best abstraction, right? So I was
Yeah.
working on containers pre-Docker using LXC. Docker came and made containers super simple, and Docker didn't have fault tolerance. So I was working on fault tolerance using a uh, research paper published by Google called Omega. So I was actually working on building this optimistic scheduler for Docker, right, or like containers. Then Kubernetes came. The scheduler was not as great as a optimistic scheduler, but it worked, and it gave orchestration and fault tolerance. And I've done some early contributions. Even my code is still currently used by Kubernetes and Terraform and all this amazing software that came about. If you look at my GitHub, you have an idea of my contributions. And So containers happen to have, they're not like the silver bullet, one would call them, but they have an incredible ecosystem that solves for a lot of problems, right? And Akash is not built to be container only. You can plug in any container sort of like not Docker only. You can put any container runtime. You can attach the container runtime. That really depends on the provider. And that's also another cool thing about Akash is you get this optionality. We'll get into that later, but it's pluggable, right? And the white paper actually proposes for a other mechanisms as well as to how you package them, how you can deploy. Yes, WASM could be a package, but we looked at WASM. Some friends of mine created formed companies to take WASM mainstream, and a lot of them didn't really succeed because even though WASM is great on paper, it's extremely opinionated in terms of how one should write an application, and that opinionation leads to a lot of friction for adoption, right? So I think the ecosystem hasn't gotten to a point where you can actually write full-fledged high-performance applications in WASM. And because a lot of times it's like, well, if you're thinking about WASM mode, you're really thinking about serverless, right, infrastructure. And serverless means heavily distributed, and at certain scale, serverless gets very, very complex and extremely expensive, right? So there is now a trend of reverse serverless, which is like monolith applications. So like Amazon Prime Video actually wrote a paper like last week, I think, or week before, talking about how they saved 90% on their cloud bill. This is Amazon Prime Video talking about savings by switching from microservices architecture to a monolithic architecture, which is anti-WASM, right? Anti all these patterns that it's very anti-pattern. And now people are questioning like, hey, is microservices the way to go? So, I mean, it really comes down to what stage and what scale your operation, your workload is at, right? Like early days scale, when you're starting off something, it's very advantageous to do serverless because you don't want the complexity of managing infrastructure and the cost of the complexity in terms of time exceed the cost of your you're going to market with the product, right? So optimize for the least amount of work you need to do in order to get to market. So serverless becomes an amazing option. But at scale, when your problem set shifted from time to ship to actually save costs on infrastructure, like if you're doing video streaming, you have to go monolithic and you have to go vertically integrated. There's really no other way, because and the reason why Apple products work really well is they're completely tightly integrated, right? So in case like Amazon Prime, where they could save 90% because you tend to save quite a lot on serialization overhead when it comes to distributed systems, because the moment you communicate from one system to another, there's always serialization, deserialization that happens over a line, right? And that cost surprisingly is extremely high. And you add verifiability and resource like estimation cost on top of it that comes with WASM. So every time you're like running, you're actually estimating the cost and you're optimizing accordingly. So your overhead for compute is extensive. That results in cost. So yes, so it really depends on like what stage, right? If you don't have scale, that overhead is manageable, but at scale, that overhead becomes extremely expensive. There is no one architecture. That's why it's very important to be general purpose. That's very important to be unopinionated. And Akash, even though it's painful at times when you see automatic replication systems that'll just move your workload wherever, but it's like you're so opinionated in replication that you're going to limit your workloads on type of what kind of replication. Now, I don't want to throw further things about the project, but I have to mention this project called Flux, right? I mean, again, they're doing their thing. They have their opinions. They have their approaches, and let market be ultimate sort of like decider as to who wins. But the challenge that Flux, they really wanted a good user experience. So when you have a workload on Flux, it actually replicates across different servers and switches over automatically. Now the question is like, who decides what is the event for failover? Like like application health checks have to do the failover. So you tend to have a failover when your database goes down. You create a failover event, right? So in order for failover to happen, you need to have an event bus. You need to have a custom health check mechanism. You need to have how the database is switched over, right? What kind of for leader election happens, what kind of how are you streaming the data, right? What kind of atomic capabilities two databases are going to incorporate, what kind of consistency you're going to have, eventual or immediate, right? That determines your so you need a lot of these. When you deploy distributed systems at scale in production, you need to be able to do these determinations that's specific to your workload. You can't just put something on the cloud and expect that to replicate. Nobody does that, right? So that's why I'm not like a big fan of like opinionated models in general as a platform. I think platforms should be extremely unopinionated. Then you can have abstraction on top of it.
Right.
Like
people can build stuff on top, and it's just more. I mean, I think this touches some of the earlier points that we mentioned as well, which is how do you just have the simplest sort of infrastructure platform that can allow people to build for these different use cases that would have built in this replication or build in different VM support and things like that.
Right, it's like Fleek is doing only web workloads. They're really good at web workloads. JavaScript, that's their jam, and they know exactly how to use Akash to scale JavaScript. And they do the opinionation, they do the abstractions for you. Sure. Speron, similar, right? Akash AI, in fact, we're doing this machine learning verticalization that knows exactly how to scale a machine learning workload and removes all the complexity of using Akash, right? So that is a higher level function in terms of these opinionated approach or workflows, as I like to call them.
Yeah. So let's talk about the GPU stuff, because I think that's what a lot of people are hoping to hear about. So we talked a couple of days ago about like the state of the GPU market, and I think I feel like you're someone who has a pretty good grasp on the state of the GPU market and how demand has been growing, and is manufacturing keeping up with that demand. So like I'm curious to maybe get your high level overview on what that market looks like right now, because it seems to be like a lot going on there.
Yeah, it's always been a high demand. If you remember, Akash has been working on GPUs for a very, very, very long time. If you remember Super Mini and all these things that we were trying, right? Um, Super Mini was supposed to be a supercomputer for the home, so you can have your own compute. So we've been, exploring GPUs for over 4 years, I would say, right? Um, and now we finally have the capability. It's very, very hard to do an open GPU marketplace. So if you look at the space, there are essentially very few companies, NVIDIA, AMD, maybe Intel, that actually make GPUs. And GPUs are extremely uh, powerful additional chips on top of the CPUs that adds acceleration. So for certain workloads, be it crypto mining or be it machine learning or be it graphics processing, GPUs tend to have these accelerated chips to power these workloads, right? And when it comes to machine learning, NVIDIA happens to have the best GPUs because their on-chip memory is much higher than your typical AMD processors, where you may have more powerful like clock speed, but your on-chip memory is small. And on-chip memory, in the sense the memory on the chip itself, that's separate from your actual RAM. And that's very important to train neural networks because neural networks are essentially taking these large data sets and breaking them into this checkpoints by going deep, and the latency between the chip and the memory needs to be as minimal as possible. So NVIDIA happens to make the chips with more memory, the most advanced chip, which we call H100, right? That's a purpose-built high memory chip. Um, uh,
Which costs like 40 grand or something. Like,
cost like $40,000, and
yeah.
if you can get it, that is, it's like a Rolex or a Ferrari, right? The MSRP is never the price you end up paying for the chip. You end up paying a lot more because the supply is extremely constrained. They're constrained by two main factors. First is they cannot make these chips fast enough, right? Um, because you know. Because the supply chain for these chips really involves a lot more companies than just NVIDIA can make them. So NVIDIA is the one that makes the chips, but they get the machines from this company called ASML, and machines. The NVIDIA gets chips from TSMC, or Taiwanese Semiconductor
Yep.
Manufacturing Corporation, that actually puts the chips on the transistors on the chip, and then you get the software to make and the machine is made by ASML, right, or something like this whole supply chain.
Yeah.
So a lot of very incredible choke points, and with COVID, it the general chip shortage because they couldn't make these chips fast enough. And second, the demand from AI just exponentially grew, right, to a point where AI research there was a lot of hype at some point, and then the hype died, right? And then there was a lot of research and innovation, especially around this mechanism called transformers, invented by Google, really, um, I think 5 years ago. And from transformers, we started seeing a whole range of large language models, or LLMs, we call them. And LLMs have amazing use cases. You have generative use cases, you have summarization use cases, you have classification, you have search, you have a lot of amazing things you could do with LLM. And one of the use cases happened to be generative use case. And so people could take a generative LLM and put a pre-trained model and create something called a generative pre-trained transformer, or GPT, right? So GPT-3 came out in 2000 by OpenAI, and a GPT and OpenAI, it's been around for a few years, and they built a user interface called Chat GPT on top of GPT that they introduced last year. That obviously blew up, right?
Yeah.
And they got 100 million users in 3 months, in the fastest ever growing. So it was a UI problem, not the technology. Technology has been there for a long time, and we've been following very, very closely. Uh, and that GPT-3 needed quite a lot of chips which are A100s. So for the longest time, OpenAI has
The
been
lower
sucking.
end chips, somewhat lower.
A100s are high-end chips, right?
But lower than the H100s.
H100s are brand new. They came out just like
Okay.
literally a few months ago.
Okay.
But
Right.
GPT-3 and GPT-4 was trained on A100s, I believe.
Okay.
GPT 3.5 at least. So, and there were, I believe, I mean, don't quote me on this. I think they're like 45 to 50,000 A100s, as far as I know, in the world. Amazon and Facebook has access to about 20,000 of these. So we know exactly where these are, and a lot of them are actually owned by the U.S. government in national laboratories, or state governments, right? So and they're so high demand, it's now impossible to get A100s on cloud. I mean, I think you can get A100 40 gigabytes, which is less powerful than the 80 gigabytes, but 80 gigabytes are just not available anywhere. Like, even if you know the cloud provider, you can't get them. People will just buy them up, right? H100s are even more hard because they're about 6 times faster than A100s for certain type of applications, especially LLM training applications. So Elon Musk bought about 20,000 of these, right? Like, or 20 or 10,000. Any company that's doing anything serious with LLMs are buying up these chips. So
Are
it's
people like
very,
selling futures for these? Like, are people like hoarding them, or
they are arbitrages
is there some of
are
this like
coming.
speculation, market
Yes.
manipulation going on? Yeah.
Oh yeah, absolutely. There's a whole ecosystem, whole supply chain, and new players on supply chain now with holding on to H100s. Um, like, there's something called distributors in the middle. So you have your chips, and you have these server manufacturers like Dell, Supermicro, and a whole lot of them. They have a whole lot of supply, and you only get H100s if you buy a server from these people. So it's like there's a lot of stuff here. If you can get access to H100s, get them, right? You can actually sell them in secondary markets. I don't know how much they're going on eBay, but people are.
I saw one on eBay for like 40 grand. Yeah, like
40?
There was one on eBay. I saw
price,
one. Yeah,
right. I mean, it's very obvious, right? And guess what? When you're sitting on these chips, when you're not using them, you have a place to go now to put them. And when you have when you have a buyer, you take the chip and put it back, right? So, sell it to the buyer. So there's a lot of like this incredibly high demand, and now with geopolitical scenario not looking so great for globalization, there is a reverse globalization. There's a lot of protectionism right now happening, and the main reason why Chinese are not there's export controls on these advanced microprocessors now. Biden signed an executive order about 9 months ago preventing any advanced micro chip sales to China and Russia and Iran, obviously, and any American from working for these companies for microprocessors. So overnight, with a signature, I think Biden killed the entire Chinese GPU industry. And so there is extreme export control on these chips. It's very, very hard to get them. I think they're even harder than getting a gun in US.
well,
probably, right?
That's not a high bar to.
That's not a high
bar to cross. Yeah.
But
so what's the like biggest problem? Like, so you guys are running a GPU test net, right? Currently, what's so different about providing GPUs, as opposed to providing just generalized, CPU infrastructure that necessitates running like a dedicated test net for this? And how is that rollout going to look like once it starts hitting mainnet?
Yeah, so it's a new type of resource on the Akash network, and GPUs are very device specific, whereas CPUs don't really care much about what kind of CPU you have. You may have, say, on AMD or Intel, but they all work pretty much the same, right? GPUs are very different. Your application is very GPU specific. Some applications are written only to work on H100s or A100s, or like very GPU specific, right? So they're they're opposite to the whole notion of a container where you can build one and run in anywhere. So unfortunately, with GPUs, you have to build a container to run on that GPU. So it's a very different way of deploying. right? It doesn't, it doesn't give the homogeneity you get with GPUs. And the GPUs and Kubernetes are extremely new. NVIDIA is the only company that has some degree of, adoption and some degree of like good software, but others don't really have the kind of penetration. And if you were to, and another contrarian view, I think you had to put NVIDIA as a software company, not a hardware company. That's my contrarian take. NVIDIA's innovation is really software, the CUDA SDK that they came out 10 years ago. That's why they're really good with AI. No one else can come. NVIDIA is good at software.
I don't think that's such a contrarian view. I mean, I have like a pretty summary like understanding of this market, but my understanding is that NVIDIA really excels at the software, and like they've really created a huge moat around that, and sort of, I mean,
most people think NVIDIA is GPUs, right? But anyone can make GPUs. I think the software that they built. Not anyone, but anyone that's
But they also have this really tight integration with the chip, right? So coming back to your analogy earlier about Apple and how that the software and the hardware need to work together. I think they've also like done that really well, and to the same extent that you might consider Apple also to be kind of a software company, right? Because they're building really good software that serves a purpose and experience, but building the hardware that is able to deliver that experience. I think the software is the interface with the person that's using it.
Correct. Yeah, I mean, they're much better phones than iPhone, right? Like Androids, a lot of Androids better than iPhone, but the cohesive vertical integration is done so well with Apple products and NVIDIA products. That's why they shine. NVIDIA is the Apple of chips.
Yeah. So is Akash going to be providing like raw access to this GPU power, or are you going to be providing access to the models? What's that going to look like for users?
Akash network is going to be unopinionated, non-custodial always, so it's going to be a raw access to be on it. But Overclock Labs is building Akash AI, right, which is an abstraction on top of Akash that's optimized to run models in a very simple way. So we're taking the user experience first approach, user first approach, and one click deploy Stable Diffusion, ControlNet, Llama, Alpaca, whatever model you want. And we're going to be extremely expressive. We're actually working with integrating Hugging Face. So any model on Hugging Face, you should be able to deploy on Akash. Any model on LangChain, these are very popular machine learning application, packages or platforms. You should be able to click deploy on Akash within like a couple of clicks and pay using credit card. Now, of course, credit cards are custodial, right? So they're not non-custodial. That component Overclock is building to specifically focus on machine learning developers that are not crypto native, right? For them, I tried to onboard a few of them in like multiple hackathons, and that was the worst thing ever. To go tell them to go give your mother's passport in Kraken and get your KYC done and wait for a couple of days to get the tokens. Right? It's just so bad, the whole onboarding. And when you talk to them about Kepler, they're like, well, what is it, a browser plugin? And they freak out because nobody wants to install browser plugins. I mean, you'll be surprised as to how anti-browser plugins the whole world is, right? So there's just there are quite a lot of these barriers for folks to see the value of Akash from a machine learning that's not crypto native, and Overclock is solving that problem. Overclock is one of the companies solving, but specifically focused towards machine learning applications.
So I was talking to someone earlier about this interview, and it's like, oh, what should I ask Greg? And I think this is kind of a good question to wrap up on. Akash is essentially like a marketplace for distributed computing, and you guys are offering now like different types of compute resources with general CPUs and GPUs. But how are you thinking about Akash over the long term, and how do you plan on transitioning to whatever the next big thing will be, right? The next big computing resource that will be in high demand. If it's not GPUs or CPUs, maybe it's like quantum compute resources or some other type of compute resource that might be like at a different abstraction level than what we're used to. What's the long-term vision here?
Very cool. Thank you for the question. So the first major milestone for Akash Network is parity with the cloud. So right now, Akash is still, from a capability standpoint, it's not equal with Amazon or Google, right? We need to get to parity. That's going to be hyper focus on the roadmap. Post parity is how we evolve, right? Right. So post parity, imagine having 10,000 providers in every city of the world, right? GPUs, CPUs, speed, whatever resource. Imagine being able to provision a workload that follows your user no matter where they go. So, when you have a future where you have computers essentially are mobile, if you think about a robot or a self-driving vehicle or any of these devices, the compute is at the edge. And in order for edge compute to function, you need to solve the communication cost problem, in the sense how long the packets take to travel between the edge device and the cloud, right? The device that's in motion and that the device that's static, right? You always need this like communication. And at that point, the only way to achieve that is the massive distribution of compute all across, and with the incentive model for these providers to provide compute on Akash, right? At scale, and the possibilities are limitless. I call it innovation beyond imagination, because now you have a network that's extremely agile, extremely high performance at the edge. And second thing is Akash is community managed, community built projects. We have about 280 contributors. Out of them, 17 folks are employed by Overclock Labs. If you look at some of our repos like Akash console, Akash network slash GitHub slash Akash network slash console, you look at the pull requests. 9 out of 10 pull requests come from outside Overclock Labs. It is a community built, and it's very critical that and we're adding about 15 developers building on Akash every month or something. We're growing really fast. Ever since we came out with the announcement of like completely radically open source on our blog in earlier this year, we had amazing participation, right? So now everything about Akash is set in the public, right? The product, the roadmap, the features, the priorities, all that's set in the public. All those meetings are publicly posted, transcribed, summarized, everything done, right? And it's
Yeah,
very,
it's
very
really
important for us,
impressive, by the way. Yeah.
very important for us to expand that, because that is what is going to get us to move faster in the future. Yes, you can go faster by yourself in the short term, but you can go further when you're together with the community. And that's why open source software at a certain scale moves so much faster. You look at Linux, you look at Kubernetes, you look at any of these projects that hit a certain inflection point and started really getting into this community contribution. That's where Akash is getting there, right? Once they take off, it becomes an unstoppable force and becomes a standard. Now, you don't look at any other container orchestration that Kubernetes. It will be ridiculous. I mean, everybody tried at one point to have their own container orchestration, right? You don't look at any other, for the most part, operating system that's not Linux, right? And you don't go try to rebuild Linux. I mean, there were a lot of different operating systems before Linux, right? So, and you have this inflection point from a community contribution standpoint. Once upon achieved, it becomes unstoppable and it becomes the global standard. That's what Akash is going towards, right? And at scale, we will have massive distribution of compute with options that are impossible to get on the cloud. Today, Akash is already offering certain capabilities where you have NVMe storage, or if you wanted a different runtime for your Docker. You don't want Docker. If you want, there are all kinds of cool like experimentation when it comes to runtimes that are happening. Some providers want to provide that as an option to the user. So you're already seeing this like branch off between what you can get on the cloud to what you can get on Akash. With H100s, we end up being the only cloud provider to have H100. So you're already starting to see this branch off. It's no longer just a alternative cloud that's cheap. It's now the cloud that you can get resources on that you can't get on the traditional cloud, right? And that's going to be the future, right? And it's very, very important for us to ensure that there's a healthy foundation that is building, both for decentralization and also evolution. The way I look at decentralization is, yes, every protocol, when you look at from a technology standpoint, is decentralized at a higher level, but you start peeling layers, right? You peel a layer, you see governance, and you see centralization of the governance, and then you peel enough layers, you see ultimately comes down to who's actually building the software. That's the biggest attack vector. Once that builder is attacked, the software stops evolving. It's very, very important for that layer to be secure and that layer to be fault tolerant. And that's why Akash is built by community builders. Overclock Labs disappears today, Akash will still be working, and we're working very hard to have this on-chain fund to sustain the development, right? We call it public goods funding, right? So a lot of this stuff we're working on will come out more publicly very soon, are geared towards ensuring that there's sustainability when it comes to evolving software. So that is our biggest moat. I think community is the key, right? And that's something money can't buy.
Yeah. Well, before we wrap up here, just a few more minutes. I want to open it up for questions in the audience. There's a couple of questions here, and one that I had also listed is, how do we deal with, material? I mean, here we're talking, the person's asking about censorship. Is it possible to host not safe for work projects on Akash? My question was more around the topic of illegal content. I know that like with Arweave, there's like governance mechanisms there to limit and take down illegal content, things like CSAM, stuff like that. Are there mechanisms in place on Akash to deal with this sort of issue?
Yes, there is active conversations on content moderation happening on Akash, right? So content moderation is a very sensitive subject. We need free speech. At the same time, we should protect people, right? There's actual bad actors abusing the system, and we saw that happen with SIA, and that led to the fall of SIA, right? So it's very, very important to have this mechanism, and we're looking at certain ways. If you go to github.com/Akash.network in community, there's a group called SIG Moderation, a special interest group. And if you click on that, you'll see all the progress we made. There is a notion of ultimately it comes down to the providers, right? Providers are liable, right? So if you're a provider hosting something illegal, you are required by law to take it down, and you need to have a DMCA mechanism to protect digital rights. You have all kinds of like the legal sort of like frameworks that are already established depending on the jurisdiction you're based on. So we are going to make it easy for providers to comply, and it's very important, right? And there's if we don't make it easy for them to comply, they get in trouble. So it's very important for us to protect the providers. So Akash as a protocol level will never censor. It's not built that way. You cannot censor. But providers ultimately are the gatekeepers, and they have to make sure that they're able to serve and protect people that they are serving, right? So so like generally what happens is we have like not all content is equal, right? So you have, from a sensitivity, you have something that have different political biases, right? We all saw what happened with Amazon taking down Parler or things of that nature. With Akash, if you have something like that, as long as it's a provider that still considers this not as bad as child pornography, and they want to serve that, that's fine with them. Akash will still function very well. But if every provider it's bad, they're going to not serve. They have complete liberty as to choose who they want to serve, right? Universally bad, universally frowned upon, they won't serve. So as long as there's a single provider running on Akash, the workload will get served, and that provider is ultimately liable, right? So and if the authorities deem that provider to be malicious, and they there's an IP address, the provider can be easily tracked. So we're not going to end up in a scenario where we're going to have a lot of illegal content and providers providers are going to know about the content and they have to take them down. And that's how network kind of like sort of like regulates itself without having a police or someone watching them from the outside standpoint.
Okay, cool. And then one more question that actually came from the Telegram group was with regards to conversations that you guys have had with, I think, Google or Microsoft over the years, and do they see you as competition? And in general, what are large cloud providers? What do they think about Akash? Are they, do they consider them as potentially like a path to, like a suitable path to offload some of their excess capacity? Yeah. Well, what's the state of your
Absolutely.
workings with large cloud providers?
I don't think I've ever said anything about Microsoft. I don't know where Microsoft came from, but I can publicly say, that this is based on tweets from employees of these companies that I'm talking about. I mean, if you go to my Twitter, you'll see a lot of tweets from folks at Amazon, the head of blockchain, folks at Google, the Web3 divisions of Google. They all are talking about Akash. They all think Akash is a critical piece of the future of the cloud. And this is public information, by the way. Right. Of course, I'm not going to details as to what exactly is functioning.
Sure. People can look at your Twitter. Yeah.
Right. But, if you look at my Twitter, I mean, I keep retweeting tweets from these folks talking about Akash, and they're really excited about it. I mean, they all acknowledge, cloud has a massive problem when it comes to efficiency of use of resources, right? And they all acknowledge, and these companies are realizing Web3 is the future. They have established teams for Web3. To make their companies more Web3, and it's very, very aligned when it comes to Akash, right? So a big challenge is like improving liquidity or efficiency for their existing users when it comes to like prepaid customers. I think they look at Akash as a solution for that problem. And second, GPUs are very hard to come by. And everybody wants to give GPUs to the users, just can't, right? Because there's no way to get them, and all these GPUs are just locked away everywhere. So Akash is unlocking this like massive underutilized resources, especially for high-end GPUs, H100s, right? So in the future, you won't be surprised to see an Amazon user using a GPU on Google, paying using their Amazon account, and actually, not leaving Amazon, because today if a user cannot get GPUs on Amazon, they leave Amazon and they go to someone else. So now Amazon has a way to retain the user and satisfy their needs by satisfying their needs, and actually work with a competitor. And Akash is the bridge, right? And that's exactly what we want. Akash is market focused, where these companies are user focused, and that's very, very important, right? So
no, that
Akash
makes
is the market,
so much sense.
And it's not, it's going to be very, very clear in a few years when all these integrations come out. And we are not in the business of announcements. We are in the business of integrations. We don't announce anything unless it's actually integrated, right? So, and because of the transparent and open nature, all the conversations are public. So if you actually participate in our working groups, we have meetings almost every week on like where the product is going, and we're very, very active. If you're not able to, there's also recordings if you have time, and it's also summarized recordings, right? So you can go through a lot of that stuff and get an idea as to who you're working with. But we're an open source, open community, and we haven't had any conversation with Microsoft, just to be clear. I don't. I know they have good Web3 teams, but I just don't, for some reason, haven't interacted with many of them. It's mostly the number one and number two, Google and Amazon.
Okay. Well, thanks for that, and thanks for sticking around for so long. I've really enjoyed this conversation, learned a lot about Akash, and we had quite a few people on the live stream. Certainly, this was probably amongst our top ranking episodes in terms of people that joined the live stream. So, you bring a crowd, sir.
Thank you.
So thanks.
This is awesome.
Thanks again, and hope to see you at Nebula Summit.
Yes, looking forward to it.
All right. Thanks, Greg.